Welcome back to Chem 101. In this video, I discuss the difference between empirical formulas and molecular formulas.
Alright, empirical formula versus molecular formula. What's the difference? Best way to show the difference is to just use some examples. So let me write some empirical formulas, and I'll write those over here, and we'll do some molecular formulas over here. So I'll give you the empirical formula first of something like HO. The molecular formula is H2O2. Alright, what about CH2O? The molecular formula happens to be C3H6O2. Alright, H2O, H2O. That's an odd one, right? It doesn't really follow with these other examples. But we'll continue and then I'll explain it. What about, we have K 2O and we have K6O3. Okay, so what do we notice here? The empirical formula seems to be the smallest ratio that we have for the same atom, for these two atoms. So what I mean here is, in the empirical formula for HO, it shows that every one hydrogen has one oxygen. When we go to the molecular formula, what we see is that that ratio is still true. Every hydrogen here has an oxygen, and there's two hydrogens, and there's two oxygens. The molecular formula is what it looks like in real life. Unfortunately, when we try to analyze compounds, we can't really see what they look like in real life. Best we can do is get their empirical formula, which just tells us the ratios. So for this next one, 1 carbon to every 2 hydrogens to every 1 oxygen. The ratio is 1 to 2 to 1. The actual formula is this over here, C3H6O2. But if you look at, oh, I think I wrote it wrong. I did write it wrong. Oops, this should be a 3. There we go. The ratio should still be 1 to 2 to 1. And so this has a 3 for every 6 hydrogens for every 3 oxygens. If we divide that by 3, you can see that it's still the same ratio, 1 to 2 to 1. Let's see. So that's all this is. The empirical formula is the lowest, the smallest ratio that reflects the molecule. It's the lowest number. Basically it's the reduced form of the molecular formula. But in some cases, like water, you can see that the molecular formula and the empirical formula are identical. And that could be true. I mean, there actually is a molecule up here that is OH. It just isn't. It's not a stable molecule like H2O2. So empirical formulas can look like molecular formulas, and water is an example of that. But most of the time, when you find your empirical formula, it's just going to give us the ratios. Here, 2 potassiums to every 1 oxygen. And that's still true when we look at the real molecule. We have 6 to every 3, and if we divide that by 2, right, we get 3. If we divide by 3, we get 2 to every 1.